During this lecture, we're going to talk about similarity, angle measurement, and congruence. These are covering 8.G.2 and 8.G.5. To start with, we're going to talk about a geometric proof. Now at this point, you do not have to prove anything, but I want you to watch and understand what goes on with the geometric proof. We're going to use the angle-angle postulate, which states that if two angles in a triangle are congruent to two angles of another triangle, then the two angles are similar. This may be the first time you see the word postulate. A postulate is a true statement. It either does not require proof or already has been proven. Now you need to remember in geometry, even if things seem like they should be true, you still might have to prove them. A postulate is a beginning point. It's used to derive the other logical statements to solve a problem or to make a proof. Sometimes they're also called axioms. So let's go ahead and use one of these, see how that works. We're going to prove that this triangle is similar to this triangle. To start with, we're going to go with our givens. Our given says that angle ABC and angle CDE are right angles. And our reason is it's given. This angle and this angle are right angles, and you can see it's given. There's little boxes there, so that's a given. And since we know that angle ABC is congruent to angle CDE. And we know that because all right angles are congruent. So we know that angle B and angle D here are congruent. Now we're going to look at angle BCA is congruent to angle DCE. Now remember, the middle letter is your vertex. So we're talking about these two angles marked in green. And how do we know? We know this because they're vertical angles, and we learned in the last lecture that the vertical angle theorem said that opposite angles are congruent. So the vertical angles are congruent. So now we can say that triangle ABC is similar to triangle EDC. And I was careful here how I labeled these because the angles have to match up. A is similar to E, B is similar to D, and C is similar to C. And how do I know that? Well, it's called the angle-angle similarity postulate. So I've now proven that these two triangles are similar. Angle measurement. You need to note that all triangles have an angle sum of 180 degrees. That means when you add the three angles together, they will equal 180 degrees. And all quadrilaterals have an angle sum of 360 degrees. So in that case, when you add the four angles together, they will total 360 degrees. Here's a triangle, and we can use the known angle sum of 180 degrees to determine the missing angle. So we take our 86 and our 44, add them together, we get 130. Since we know that combined they're 180, we can subtract the known 130 and get 50 degrees. So our unknown angle is 50 degrees. On a quadrilateral, we know that we have a 360 degree angle sum. So again, we can add the known angles together, combine they equal 246 degrees, take the 360 known angle sum, subtract the 246 degrees, you get 114 degree angle sum. Make sure you write those down in your notes. Near the end of your study guide, you will have a check for understanding. This one's not labeled, but please stop the video right now and do this. Again, we're dealing with angle sums. Remember, a triangle has an angle sum of 180 degrees, and a quadrilateral has an angle sum of 360 degrees. Let's go on. Congruence. What does congruent mean? Congruent means it's exactly the same, having the same size, shape, and measurement. Corresponding parts. When two figures are congruent, there are matching parts for the two figures. So when two figures are congruent, when they have exactly the same size, shape, and measurement, there are matching parts. And these matching parts are called corresponding parts. Now let's look at example 1a. We are going to complete the congruence statement, which is this statement down here. Now looking at this, it says triangle PRQ. That's PRQ. So a triangle, this triangle. Now note the direction I stated that. Is congruent to what? As we look at that, let's realize that this is 50 yards right here. And where's 50 yards on this triangle? Right there. After the 50 yards, we have 21 yards. Where are the 21 yards on this one? And likewise in blue, we'll do 45 yards and 45 yards. Now we could have done this either with the angles or with the sides. It doesn't matter, but we need to make sure that we are labeling this in the correct order. On this one, we're going from P to R. So on this one, we have to either go U to T or T to U, because we have to go along the 50-yard line. And then we're going to go from R to Q, which is 21. So we go from the 50 yards to the 21, we need to go from T to U to V, and then follow 45 back. Do you see how I went in order? So my answer is going to be T, U, V. And yes, the triangle needs to be in front. Make sure you fill that in correctly, and it's very important that the names have the congruent angles in the same order. Here's example 1b. The same holds true for any shape. So from D, E, F, G is congruent to. Well, this starts at E, goes along 34 to F. So we're going to start somewhere here and go along 34 to the next side. So we're going to start at X, go along 34 to U. And then from F we go to G. So from U we'll go to V. And then finish this by going around. So E, F, G, D is going to be congruent to X, U, V, W. A check for understanding problem. We are going to complete the congruent statement. It's a good idea to stop the video now, find that example, and complete it. And let's look at the next example. We're going to check the box that represents the true statements. Fix the incorrect statements so they are true. The first statement says angle K is congruent to angle T. So we're looking here and here. Is that true? They're both 34 degrees, so that is true. The next one says IJ is congruent to TR. Are they congruent? You're correct. They are not congruent. IJ is in effect congruent to this one. Now look carefully. It went from I to the right angle J. So we want to label R to the right angle S. So we're going to go RS instead of TR. Angle J is congruent to angle T. Well, here's angle J. This is angle T. Well, they're not congruent. J is a right angle. What's the right angle? That's correct, angle S. So angle J is congruent to angle S. And finally, we have JK congruent to TR. Well, that's not true because JK is 31 kilometers. So what's really congruent to is we're going from J to K, so we have to go from the right angle S to T. So this needs to be S to T, and it's a segment, so we're going to put a line across the top. We have a check for understanding near the end of this packet for you to try. Do it the same way as the one we just did. In example 3a, we are looking at triangle JIK, and we know that it is congruent to PQR. So we know that angle J is congruent to angle P. Angle I is congruent to angle Q, and we know that angle K, since it's listed last, is congruent to angle R because it's last. In this case, we want to know what JI is. Notice here J goes from the green to the blue. We want to know what that segment is. So over here, I matched them up. J was matched to P, and I was matched to Q. So it's congruent to this side right here. So that tells me that JI, which is congruent to PQ, is also 50 millimeters, because that's what congruent means. So my answer is 50. Look at B. Figures are congruent. We want the measurement of angle G. Well, I need to figure out which ones are congruent. I have a 19 millimeters here, so H is going to be the same as W. G is going to be the same as X, because the 19s match up. And I know what angle G is. Well, notice G is green. They match. 98 is 98, and G is next. X is next. So my answer is 134 degrees. I have to rotate these so that they match up, and then I know that they are corresponding locations. You have a try this and a second try this. So do both of these. Now's a good time to do them. So stop the video. Do these. Again, they're found near the end of your packet. And we're going to talk about exterior angle theorem. States that the measure of the exterior angle of a triangle is equal to the sum of the measures of the non-adjacent interior angles. This says that the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. These two added together is going to equal 4. So what this means is when we solve problems, angle B is going to equal 39 plus 102. So B is going to equal 141. And this problem, we're going to have 164 is going to equal V plus 129. Well, you know how to get the variable alone. Keep your equal sign directly underneath. Borrow as you need to. So V ends up being 35 degrees. You have one try this. Actually, you have two. You have one page of try this. Go ahead and try it, showing all the work. Make sure you're showing the work like you should be right here for both of these. And I will check them in class tomorrow.